Hello, everybody, and welcome to this month's Footsteps to Mars Hangout. My name is Tony Darnell. I'm from DeepAstronomy.com, and you are joining our monthly experience and discussions of getting to Mars, our early efforts in getting human beings to Mars. And so if you've never been in one of these Hangouts before, I just wanted to take a few minutes to introduce it to you. This series we've been doing on the first Friday of every month, but I think in September, and Harley and I are still working out some of the details on exactly the time, but starting in September we'll be moving these Hangouts to Thursday. So starting with the next Footsteps to Mars Hangout, we'll be doing this, I think, one day earlier. Instead of on Fridays, we'll be doing it on Thursday. So watch for that. Follow us on Twitter and everything else, and on Deep Astronomy, the Deep Astronomy YouTube channel, and you'll get notified of all the live events that are coming up. Also on Facebook, I'll make sure to make a lot of posts on there as well. So what we're trying to do here is stimulate discussion and let you guys know, the general, just people who are interested in getting to Mars, know what our efforts are and what we're trying to do in our early stages to get human beings to the planet Mars. And we've talked about a lot of different we've had a lot of guests in the past, but most of them, we have the endorsement of the American Astronomical Society and the American Astronautical Society, and Alberto and I are still trying to figure out good ways to join those two acronyms into something that makes sense. But we're calling it AAS squared right now, yeah. But anyway, we highlight science and research and engineering things that are being done by by members of these two organizations, and we bring them to you each month. And so we would like to invite you, since this is a hangout on air, we'd like you to interact with us. If you've got questions or comments, we want you to make them to us. The best way to do that, in fact, right now the only way to do that, and I'm going to be changing this on in September. But for now, the best way to interact with our guests is by using the Footsteps to Mars hashtag on Twitter, and I'll be looking at that and I'll be reading your comments now. I have it up right here on my laptop screen so I can read them off as we go along. So that's the best way for you to interact and leave questions and comments. So let me get to introducing my co-hosts, and then I'll introduce my guests. So joining me, as they do every month, are my co-host, Dr. Harley Thronson. He's an astronomer at NASA's Goddard Space Flight Center. Hi, Harley. How are you doing?
Hello, Tony. How are you? Hello, Alberto.
And that brings me to Dr. Alberto Conti. He is the innovation scientist. Well, it starts with an I. Innovation scientist for Northrop Grumman. Welcome, Alberto. It's good to see you again.
Good to see you, everybody. Hi, Harley.
I've got your JWST and Hubble paraphernalia in the background too. I see. That's pretty cool.
As usual, yeah.
As usual, yeah. Okay, so my guests this week are we're talking a lot about the emphasis this week will be talking about the efforts that NASA and the International Space Station are doing, and some of the things they've got going on in helping us get to Mars. And joining me is Dr. Sam Scimemi. He is the Director HQ at NASA HQ for the International Space Station. Welcome, Sam. Can you tell us a little bit about yourself?
Thanks, Tony. Well, I've been here at NASA headquarters now for about 10 years or so, and but I've been with NASA, gosh, for about 30 years, working at the Johnson Space Center out in California at Ames. Used to work at Goddard along there with Harley, but these days here at NASA headquarters, we're all about trying to get the most use out of the space station that we have. Many people may not know, but we've got 6 people on board station right now in low Earth orbit, and we've been on orbit now constantly for almost 16 years now. And a lot of what we do up there is do the research and technology development that'll eventually take us to Mars.
Great. And also joining us is Dr. Andrea Riley. She is, I believe you're also at NASA HQ. Is that right, Andrea?
Yes, I'm at NASA headquarters, and I work for Sam in the Space Station Division up here. Prior to working in the Space Station group, I worked in the Commercial Cargo and Crew Development Group, and I've been at headquarters for about 8 years, and I was down at the Kennedy Space Center before then.
Great. All right. Well, as I mentioned, we are going to be focusing a little bit today on discussions regarding long-duration human space flight, or some of the studies being done in the ISS, well, and how it fits in with the timetable and the mission itself to get us to Mars. So, Sam, I wonder if you could just give us a little background of, tell us some of the highlights of what's going on with the International Space Station as it relates to our wanting to go to Mars.
So folks might be familiar with the one-year crew and the twin study that we just conducted on board the space station with Scott Kelly.
That's right, yep.
And Mikhail from Russia. This was a major milestone in our activity and to do the human research and performance research needed to send people on long-duration human spaceflight missions. Today, we only have data basically for 6 months at a time. So this last mission, the one-year mission, was to start to gather data that will round out what happens to your bones, what happens to your muscles, what happens to eyesight, what happens to your psychology, all those things that are necessary to spend long times in deep space. Going to Mars is anywhere from 2 to 3 years out away from the close proximity of the Earth. So doing that kind of research is really critical to being able to send humans to Mars and get them back safely and relatively happy to come back.
So So you were saying that prior to the Scott Kelly trip, and I want to get into some of the details about what you learned from that in a minute, but up to now, do you say the baseline has been up to that point only about 6 months worth of data at a time? Is that right? Is that because that was the typical tour of most?
No, that's the typical tour. So we picked that as the basis for collecting data. Scientific research is also not only based on the actual research being conducted, but what we call the number of subjects. So we picked 6 months as sort of the compromise between number of subjects and the length of spaceflight. If we could do 3-year missions possibly, but then our number of N goes way down, and you don't have a statistically significant sample set of subjects.
So you need to match up the length of time in space with the number of people that you've got being up for that length of time.
That's correct.
Okay, because otherwise you've just, like right now with Scott Kelly, we've got 1. N equals 1, right?
Well, we've got 2. we got Mikhail too.
That's right. That's right. Okay, that's right. Thank you. So yeah, we want to get as many as we can, but most people tend to stay up there, you say, for about 6 months, right?
Yeah, 6 months at a time. Right?
Okay. Well, so what is with the... Is it only about long duration space flight or human effects of space that we're mostly interested in at the ISS, or is there anything else that's being?
No, so there's the whole list of things associated with humans. How do you keep them alive? The life support system, the quality of the water, quality of the air, fire suppression, and monitoring, radiation monitoring, and mitigation strategies. So everything that we sort of take for granted here on the Earth. When you wake up in the morning, you don't have to worry about that there's oxygen in your room. You might have to worry about if there's food in the refrigerator, but you can pretty much go to the grocery store or go to the restaurant. Yeah, you really don't have that ability on board space station or in space. Everything has to be there for you. Going to Mars is not anything like staying in the near proximity of low Earth orbit. What we have today in space station, and Alberto, if you can put up that second graph I sent you.
I'll do that. Yep. Keep talking.
What we're sort of doing in space station.
Oops, wrong one.
Wrong one.
Yep, it's coming.
We're sort of, if you will, car camping in low Earth orbit. We have all kind of ability to bring stuff up to space station, bring stuff back. We are near real-time communications. We can come back home almost any time. So you got this basically umbilical cord between the Earth and space station. Going to Mars, if you go to the next slide,
yep.
There's nothing. You have to take all your logistics with you. There's no return home. There's no quick return home. The communication delay back and forth can be up to 40, over 40 minutes. So we're learning how to break all those chains on space station, all the logistics chains, the exchange of crews and things of that nature, how to recycle, all those things.
Okay, we're starting to get some comments on Twitter. I'm noticing you guys, Andrew Planet, welcome back, and George Caldwell, thanks also. I'm going to get to your questions here in just a minute, but I'm glad that we put this this slide up. If you could go back one, just real quick, Alberto, the one with the car camping, yeah. So these are the basics of what we're doing right now. For those of you who may not be familiar with what are the ISS, it's only 400 kilometers above our heads, so that's not very far, and we have all these different things connecting us to the Earth. But there is still a lot, I guess, that the ISS can be teaching us about this, specifically long duration flights. But is it high enough in its orbit to study things like the effects of radiation, let's say? I mean, is it still within the protection of the Earth's magnetosphere, or is it really comparable to what they would see in deep space?
So the being inside the Van Allen belts helps out with the a bit of the solar radiation and galactic cosmic rays and the like. However, we've done a really good job on station learning how to monitor such things, and we've done tests on how to create some kind of radiation shielding by using packaging and your supplies. Now, we've done a lot of tests on the ground of what space radiation does to people and what it does to other organisms and the like. So we've been able to extrapolate what that will mean in deep space, but eventually we have to actually take all what we've learned and actually take it to deep space, take it to cislunar space, and then actually just, if we will, validate our models, validate our monitoring, validate our mitigation strategies. So we will have to develop all those things on station, then we'll just validate, hey, our models were right, and things of that nature. And that's what Andrea is working on to bring us to the next step into cislunar space.
Okay, why don't you, before we go to that, you mentioned cislunar space twice. Can you tell us what that is?
Cislunar space is an odd term. It just means the environment around the moon. It includes Lagrange points, far and near, a number of different orbits, just anywhere. It's just a general space around the moon.
Okay. So Andrea, he mentioned that you're working on the next phase of this whole thing with respect to the ISS and getting us to Mars. And I wonder, can you do two things? Can you tell us a little bit about the time scale of the ISS currently? How long has it been up? How long is it supposed to be up? And then what are you doing to look past that time? And what are you hoping to have set up?
Okay, well, Sam might be able to provide the specific dates, but what we're trying to do is to do all of the Mars-class system testing while the space station is still in orbit.
I'm sorry, say that again, the what?
The Mars-class subsystems, so
okay.
like environmental control systems, the health and human systems, and things like that, to test them out in on the space station before we put them into a deep space habitation capability. And we hope to have a shakedown cruise of all of the Mars-class systems in deep space by the end of the 2020s.
Can you give us an example of what a Mars-class system might be? Just pick what would be something you'd want to test on the ISS specifically?
Yeah, I think I sent actually a chart. It has a lot of colors on it, and it actually
colors. Yes, I found
we like colors.
There you go.
Ooh, there we go.
No, not that one.
No, this one, this one, this one. No.
No.
I only
Maybe
have this.
I didn't send it. But we have.
Oh, is it this one? I think I have it. Is it this
You might
one?
have. I have this. All right.
No, it's not that one. But the systems include things like the life support system, the environmental.
That one.
Yeah.
Yeah, that's the one.
Yeah.
Which I don't have. Yes.
Okay.
Yeah, so you can see it lists all the systems from crew health, radiation protection, fire safety, logistics, and then there's a column that says the capability that we have on the space station today, and the capabilities of the systems we'll need for deep space exploration.
So on the example with let's just pick one, radiation protection, you can do these things that are in the something node 2 quarters. You can look at real time doses and dosimetry, as well as all these different levels that people are being subjected to, I guess, while in orbit around the Earth. But then the deep space ones would have other things in them, presumably that would only be exposed after they get further out from Earth's orbit. Is that correct?
I believe so. Sam?
Yeah. So what Andrew, what you pick on that one. So we
I just picked it out of the blue, but you can pick anything else if you like.
So for radiation, right, on station, it's mostly aluminum, and we've got aluminum structures characterized pretty well. And we just flew the Bigelow test module, the beam experiment on board station, and now we're characterizing the radiation environment inside an inflatable structure. So we're going to take that data and then use that in our future designs of the pros and cons of aluminum versus an inflatable fabric structure.
Now, I have a question for either Andrea or Sam. We've got the two colorful columns. The column on the right, are those in general specific for a post-space station habitation system, or what might be experimented with on the space station before you go into deep space?
So you're talking about the far right column?
Correct. Yeah. The one on the right.
Well,
Yeah,
so
so
deep space.
the far right column is what we would actually do in cislunar space. That's the goal.
Okay.
See, in other words, that's the goal we want to either demonstrate or validate in cislunar space, and that's driven by what the Mars class missions need. Take, for instance, for Eclipse, we want a mean time between failures, which is an engineering way of saying that, hey, how long does this thing work before it breaks? Right now, it's about 6 months for Eclipse for the environmental control sim. We want to go up to 2 years or so for our systems, and that's what we want to develop and test on the station.
And maybe this is more of a question for Andrea, which she gets back. Although Sam, I'm sure you probably know this as well. So if things go smoothly in the mid-2020s with these next generation habitation systems, we'll be discussing a little bit more of them in a bit, is the plan then that all key elements for human missions to Mars will, in your area, will be established, that they will be proven and ready to go?
I think we lost Andrew.
So, question for Sam.
Okay. So basically what we want to do is on station do the initial testing and ring the systems out and take those systems, takes the next version of those systems, build basically the Mars spaceship in cislunar space around the moon, then conduct basically what we call a shakedown cruise, basically have a crew in this Mars spacecraft vehicle for up to a year or so, and basically simulate a mission to Mars while you're still relatively close to the Earth. They'd be in it for a whole year without logistics, without crew exchanges, with communications delay, and all those things that make a Mars mission what it is.
But this would be, so Sam, this would be cislunar, not necessarily. I mean, would this be like a structure like the ISS into orbit around the moon, or L1, for example, or what is the thought?
I don't think the orbit matters so much specifically, because all these orbits pretty much have the same environment.
True.
Other than the low lunar
correct
orbit.
I
They
see.
all pretty much have the same environment. And we want them to be would be demonstrating, shakedown cruise is a naval term. Before you take a aircraft battle group, all the way around the world, you go out, instead of going to the Indian Ocean from Norfolk, you go to Bermuda.
Yes.
Oh, good. So I'm glad we got you back, Andrea. we lost you.
That's okay.
We lost you for a sec there. So I want to talk just a little bit about the basic, before we go to the post-ISS era, a little bit more about the ISS itself. Now, it's been up for quite a while, right, Sam? And how much longer is the ISS expected to be operating, and what are NASA's plans going forward?
So the first assembly flight was back in 1998.
I know, it's been around a while.
It's been around a while, and you know, I've been with the program now for most of my career, I can say now. Right now, from a, if you will, policy standpoint, it's going to be up there at least till 2024, and all the international partners that we have, as you may know, stations a partnership between Russia, Europe, Japan, and Canada, and of course the United States. So at least 2024, and although the partners have approved to 2024, except ESA, and they'll be doing that this December. We really don't have, the ISS will eventually have a structural life. We think that's around 2028, but we're really concentrating on utilizing station to make sure that we've done all the research necessary, do all the technology development, do all the human research activities on station before we actually end the program. So we don't actually expect it to end, you know, directly in 2024, but sometime in the mid-2020s we expect that we'll complete all this research, complete all the technology development we need to go to Mars in the mid-2020s.
Is that the point? Oops, I'm hearing an echo. Is that the primary driver going forward for the ISS? Will be the Mars-related activities, or are there other things that ISS is concerned with?
Yeah, so that's just one of our main 4 pillars, basically. One of the other main pillars is to do research that benefits people on Earth. We do quite a bit of research in other fields in physical sciences and biology and the like, with not only NASA research, but research being conducted by NIH into cancer. We have pharmaceutical companies doing research on station through the National Lab. They're doing drug research and application research on board space station. So there's a lot going on besides just our exploration-related research. We're also in efforts with the National Lab and our organization that runs it, CASIS, is we really stepped up our development of the commercial market in low Earth orbit. We started with commercial crew and commercial cargo. We just put out an RFI to look at, see if anyone's interested in bringing up a private module to space station to be able to use. So those are some of the major elements on board space station that the program actually is a broad spectrum of activities.
So in addition then to getting the research we need to understand the effects and the subsystems and all of that we're going to need to go to Mars, we're also looking at using the ISS for commercial applications and other research areas that are hopefully going to be making space a little more cheap, hopefully to inhabit, or at least safer.
So Sam mentioned something actually I thought was kind of interesting. You use the word structural lifetime for the lifetime of the space station, so to speak. So when you build a new generation of things, are you also looking at how to keep them, you know, structurally sound, if you will, for much longer periods of time? So is there a lot of work going into that as well, or are you just starting?
No, what I would say is that the original structural life of the space station was designed for 30 years.
I see.
And what I would say, modules themselves have a much longer structural life. The modules themselves, where structural integrity starts to be not so robust, is all of the mechanical. Everything that's got a moving part.
Yeah.
Moving parts are going to fail at some point in time. So our docking mechanisms. Some of our structural elements on the outside of space station will end up having a structural life. All the big mechanisms, like the big Sarge that turns the solar array, big solar array joints, that nature. Moving parts will have a limited life, and some of these moving parts are just too complex to replace. But we'll get to that as we reanalyze the structural integrity of station every year. So we're monitoring it. We'll know how much margin we have. It may be possible to go well beyond 2028. We just don't know until we get there.
I see.
So Andrea, does that figure into your plans, the structural lifetime, and what do you envision being the next steps, I think, beyond the ISS? What are some of the things you guys are thinking about?
Well, right now in our planning, we're working on kind of a three-phased approach, and right now we're in the first phase, and this is looking at initial cislunar habitation capabilities. And we have some study contracts with 4 companies right now, and those will be, yeah, that's the slide right there. So these are their concepts. We have study contracts with, you can see Bigelow, Orbital, Boeing, and Lockheed Martin. And those will be ending later this summer, early fall. And we're right now in the process of making selections for a phase 2 of this initial habitation capability development. That's looking to mature their concepts, while also we're looking for a ground prototype unit by 2018, and while also we're looking for our investments to stimulate any commercial activity for habitations in LEO. So we're working on that right now, and we're on track for selection of that in early August.
Okay, so help me understand. So phase 1 we're looking at now. You're hoping to make selections based on some of these plans, and then what was? How did phase 2? Would this be a different set of companies or the same contractor?
It's a competition, so
okay.
It'll be a selection. We did offer the opportunity for other companies to put in proposals, so it was open to anybody who submitted something. And so the purpose of that will be 12 to 18 months maturing the concepts while also building a ground prototype unit. And so this picture is just the phase 1 companies. So I can't say too much about phase 2 because we're right now in the selection.
Sure. Okay. Well, so the International Space Station was designed more or less as a general purpose. I may be mischaracterizing it, but it had a much broader mission envelope than just going to Mars or studying going to Mars. Lots of things can be done on the ISS. Are these things that you're looking at now, Andrea, these things that with these phase 1 habitats, are they Mars specific, or are they also going to be kind of general use and purpose habitation units?
So these initial habitation capabilities will be used in cislunar, and we're still, coming up with interface requirements and standards and things like that. But they could be used to augment the ARM mission, and it provides more opportunity to extend the Orion missions, the initial missions. And so this is probably like the mid-2020 timeframe.
Okay, and Orion is the next heavy launch vehicle that's currently being built now and being tested at NASA to get us out into beyond cislunar space, correct?
Orion is the capsule that the crew will go in, and the space launch system.
The space launch system is the main is the main heavy lifting vehicle for it. Okay,
get your acronyms right.
What?
Get your acronyms right.
They keep changing too,
I know.
All right. Well, let's talk about what we've learned. So we've been up there with the ISS. We've had some things that we've looked at, that we've tested. We've had Scott Kelly up there for a year, and we've also, I think you guys have set fires up there now. So what are we learning? Are we ready now, or what? Let's start with, and I'll let either one of you comment if you want to on this. Let's start with the long duration human aspect of being in space. What have we learned so far?
Yeah, Tony, what I would tell you, the first thing we learned, we don't want to build another space station. Okay, we've learned that much.
Like what we've got up there now, you mean?
Yeah, what we got up there now, and we don't want to build another space station after this one's over with, and we definitely don't want to build a space station in cislunar space. Whatever we build in cislunar space, because of the high cost of access, is that you want it to be more mission specific, the mission narrowed down. Like you said earlier,
yeah.
Station is, it's multi-purpose, right? The station we have today is multi-purpose. What we build next in cislunar space will be more targeted, along the lines of the shakedown crews actually, trying to wring out what it's like to go to Mars. But as far as the human side, for the human research side, we're starting to learn that we probably have a lot of the tools and mechanisms to be able to keep people alive, astronauts alive and healthy, for long periods of time in deep space. So we have learned that through exercise and diet and medication, is that we're probably within a few years of actually validating that for sure, that hey, we've got all the tools, the procedures, the nutrition and all that all worked out to go to Mars. And by our human research program, they have plans by the 2024 time frame, or about then, that they will have all this wrapped up in a bow. So we're
wow.
But this is significant, and by that time, also we will have the Mars class life support system tested on ISS. So about the same time, we will have the biology figured out, the medicine figured out, the technology figured out for life support by the mid-2020s to send people to Mars, at least in orbit missions to Mars. So yeah, it's coming.
Well, I can imagine that almost by definition, space is not a very healthy place to be. I get that part, but what do you think as far as the human physiology aspect of being in space, is there anything that is particularly sensitive that we have to always be vigilant? Like, is it things like muscle atrophies, or is it bone loss? What are some of the biggest dangers and things we've got to protect our astronauts against when they're up there?
So our bodies weren't built really to be
right.
So muscle mass, a loss of muscle mass, loss of bone mass, vision impairments. Those are the things that we're learning. There's other long duration in deep space issues with with your nervous system being in deep space because of the galactic radiation that we have yet to understand.
Did you say galactic radiation?
Yeah, galactic cosmic rays.
Cosmic rays, yes.
These are sources outside of our solar system.
These are
from the galaxy itself.
Harley can talk more about it, but these are heavier particle radiation that really wreaks havoc on the human body.
Yeah.
Wow, I guess I would have been more concerned about the sun being a big factor, but I guess not the galaxy.
Actually, the sun, we know how to shield for the sun, so the sun is not really a problem. We know how to. So
X-rays and the high energy rays from the sun, we've got that.
We can shield for that.
Okay.
How to do that?
Yeah, but the cosmic rays, we don't really have an effective, feasible shield for the cosmic rays.
I mean, theoretically, we could come up with a force field like you have on Star Trek and things of that nature.
Now you're talking.
Well, the Earth's atmosphere is what protects us from a lot of this from now. Right? So
and the magnetic field.
And the magnetic field. So that protects us from our own galaxy. But once we get out there, Harley, I'm sorry, that's just amazing to me. So the galaxy really is that harmful of a radiation source for us once we get outside the protection of the Earth.
I mean, is that surprising to you, Tony? I mean, there's a lot of very energetic.
The background, yeah, it does. I mean, I could see gamma ray bursts. I could see things like a star exploding, or things like individual sources, not a background of galactic radiation
all the time.
Yeah,
that's interesting. Right. That's very interesting. I'm glad. So that's cool. All right.
Yeah. Well, it should be known that comes from specific objects within the galaxy. Not just it's not a background. It's a different topic for another time.
Oh yeah, okay. Well, but that is a big threat. So, and then things like, so we've all seen the movie The Martian, and how he was able to eat and survive by using potatoes, growing potatoes.
Well, part of the plan is to send loads of potatoes.
Yeah.
Andrea can speak to that. It's part of the program that she is overseeing.
Okay, go ahead. So
they fill Orion with potatoes. Is that what they do?
And so, what are some of the? So, is it just a matter of eating a balanced diet, or is there anything special we've got to make sure they can eat when they're up in space? Anyone?
Yeah, well, so a human body needs a balanced diet, right? So you need your vegetables, you need your protein, you need your carbohydrates. You need all those things. same on Earth as you do in space. So, and today, as one of the research that we're conducting, food starts to lose its nutritional value if it sits on the shelf for a long period of time. So that's another area of research that we're exploring as well.
Okay.
Is there any research to, we see all the time in sci-fi movies, artificial gravity. We saw it for God's sake, in 2001, right? Back in 1960s or something. So is there any way that you guys are thinking of to mimic the effects of gravity itself by making the spacecraft rotating, for example, or doing something like that?
Well, Andrea, I don't know if you want to add anything to this, but on the movies, they never show the vestibular effects of going from a rotating
correct
to effectively a part of the spacecraft that's not moving, right? So if you ever spin around, the diameter of a spinning spacecraft would have to be
very large
for your vestibular.
Otherwise, you're just going whoa.
Yeah, they don't show them coming out of the rotating structure into the still structure. I mean, if you did that in real life, they'd be spinning around. They'd be all disoriented.
Like the merry-go-round on a playground.
They'd be throwing up. None of that is shown in the movie.
That's the sci part of sci-fi.
Right. So that's probably problematic. And the research we're doing on space station is showing us that through exercise and diet and the like, that we can actually mitigate the effects of weightlessness for longer periods. I don't know, Andrew, you want to add anything to that?
No, I think you covered it all. I don't know of any NASA studies that are looking into it.
Okay.
Well, I was asking, here's a question, I think, once again, maybe for Andrea, when you were offline just for a little bit ago, I asked Sam, but I'd like to give you a chance to answer this as well, or Sam to update us. If the program, if the systems, the habitation systems that will be built eventually for the middle of the next decade are successful, the technology has been developed, the ecosystems have demonstrated their usefulness, the food has been developed that can last sufficient lengths of time, will that then check off all the necessary capabilities so that the next step will be the mission to go to Mars? That is to say, Andrea, the proposals that you're seeing.
I have Andrea answer that one.
Yeah, exactly.
So once all of the systems are developed, the ones we talked about, like on that page, and then what we want to do is have that shakedown cruise at the end of the 2020s to validate all of the Mars class systems, and then after that, the plan is you want to make sure you do the shakedown cruise before going to Mars, the Mars vicinity. But having all those capabilities should enable whichever mission scenario should be chosen.
Harley, if I can add to what Andrea said, is that once we do finish and validate, hey, did the shakedown cruise go well? First of all, did the environmental control system work correctly and things of that nature? Does the transportation system, the prop modules and the like, all work correctly? And then we're ready to leave the Earth-Moon system. Now, whether we actually go to Mars or go to an asteroid, do a flyby, or do a Mars orbit mission, that's left to the future. But we want to be prepared by the end of the 2020s to actually at Mars, at least to do an Mars orbit or a flyby mission.
Okay, we're starting to get quite a few comments on Twitter, which I want to get to and read here. But before I do that, I just want to talk about the role of private companies in Mars. That's something everybody has been asking about a lot recently, especially after some of the comments from people at SpaceX and stuff about how they're going to go to Mars. And I recently read, I believe it was just this week, that the permission was given to MoonX to land on the moon by the FAA. And so my first question is, do private companies need permission to land on Mars? Because I didn't know this, but apparently they need permission to land on the moon. And is there an analogous thing for Mars? And how does NASA work with these private companies? Anyone?
Well, I think there's two answers. I'll answer the bigger question, and Andrea has been working with private companies
Okay.
for a long time. There's actually something called the Outer Space Treaty, and where these kinds of things must be not necessarily regulated, but reviewed by the host country to ensure that they're not they're abiding by the Outer Space Treaty itself. They're not interfering with other countries' activities in space and things of that nature. So yes, there is some level of review for such things that is required.
So for SpaceX, for example, to want to go to Mars, they're going to have to do something similar than what MoonX did. They agree to these treaty specifications, right?
Moon Express.
Yeah, Moon Express. What I say? No,
MoonX. There are too many X's.
Oh, yeah, I know. Well, MoonX, SpaceX, yes, but Moon Express. I'll call it
Moon Express. Yeah, that's all right.
Yeah. So I expect that he'll have to go through something similar.
Okay. All right. And so, Andrea, can you comment? I mean, you've talked a little bit already about the contractors working on some of these phases at the habitation modules and things like that. These are contractors with NASA. What about private companies doing things like, I guess, SpaceX and Moon Express and these kinds of? What's NASA's role in working with these guys, or do you guys work with these guys very much?
Well, I would, if it's not part of a government program or investment, then I mean it would be if the company wanted to work with NASA, they could come to us.
Okay.
And in fact, SpaceX has come to us. We had a joint announcement with SpaceX about we're doing some analysis for them, and we've got a tool set that isn't commonly available on how to get to Mars, and the characterization of the atmosphere and things of that nature. So NASA is basically the holder of much of that information.
Okay. All right. Well. Alberto, were you about to say something? I'm sorry. Did I cut you off? Okay. No. So let me get to some of these comments here. So
it's a first, by the way. So.
Pardon me?
It's a first. You usually cut me off, but it's a first.
Well, yeah. Neville Madden is commenting, I'm watching on YouTube live stream from Australia. Well, welcome, Neville, and thank you for watching. I appreciate that. And let me go back to the beginning. Andrew Planet is asking, he says that Charlie Bolden has also favored robotic missions. Could we integrate robotic missions with astronauts to make it easier?
Well, they will need to be integrated together. So it's not, robot. This is not iRobot or Transformers or anything. This is it's not humans versus robots versus humans. We'll be
almost certainly there's going to be some sort of symbiosis.
Yeah.
Yeah. Well, in fact, actually, Sam, isn't the case that there already is a reasonably effective robotic system on the space station now?
In fact, that's where I was going, Harley. Is that we're already doing this on space station.
Right.
Robots are an integral part to human spaceflight. We have the ground controlling robots on board space station, making repairs on the exterior space station right now. Yeah. So the astronauts aren't even required to do some things on the outside, and robots through human control are actually doing them right now on space station.
So almost certainly there'll be something involved in the mission to Mars. Yeah.
Something similar, like human-controlled robotic rovers on the Martian surface there in real time, right?
Yeah.
Control the cats walking.
Yeah, one of my cats walking by me.
And I know we could have robotics in the shape of these little rubber duckies, right, Harley? We could just we could have them out in our gravity. There you go. And see, I worked it in for you.
Cats.
So they could turn
also, and maybe the point that your correspondent was saying is something, and Sam knows about this, he's been involved in this, is that the scientific community, the Mars scientific community, has been working increasingly closely with the human exploration community for Mars, coordinating the kinds of studies that both will need if and when we have both robots to do science and humans on the surface of Mars to do science.
Okay, so let me get to another one. George Colwell, welcome back, George. It's good to see you again. Will we have to invent materials in order to get to Mars, or can we harness the power of materials like carbon nanotubes? And this is coming back to, I guess, in a reference to things like JWST, the James Webb Space Telescope. Things had to be invented for it to be built. Is there something still, things that we just are going, well, we're going to need to figure this out at some point before we go to Mars? Is there anything like that going on?
Yeah, so one of the biggest challenges is landing large masses on Mars. Today we've only landed 1 metric ton, and that's it.
Yeah.
So,
Was the biggest Curiosity, was that the largest?
yes, the last rover was the largest.
Yeah, that was the SUV size rover.
So there are some technologies yet to be invented and demonstrated. But to go to Mars, get to Mars and come back, without landing aside, that technology and the research is just about here. We're talking in the next handful of years, 6, 7 years, is that we'll have the technology actually needed to go to Mars and come back. So that's imminent in human spaceflight terms.
One of the things I've always found interesting, that I don't know how people do it, but when they make these timescales of how they're going to build and develop a mission, it's always I think they factor in this, what we don't know, and the rate of discovery into the mission timeline somehow. Because if you just started with what you know and built a mission based on that, and don't take into account new technologies being developed, new knowledge that we didn't have before, it would take a lot longer. So you kind of build in, I think, to these mission timelines, new research, new discoveries. Am I right?
Yeah. So, and Andrea can talk about this, about incorporating new technologies, for our private industry partners. But basically, as you learn about new technology and how it gets incorporated, like on Space Station, station was started, and the internet was just, and Ethernet was just a baby. Not very many people knew what it was when station first started, but now we've retrofitted station with it, and it's got wireless, it's got all the latest technology of the internet on board Space Station. In fact, we can run the internet across the air-to-ground links now for space.
Yeah.
And Andrew may want to add some more for what we want to do for deep space.
Okay, so did you want to add anything to that, anyone? Okay, so my next question is from Kenneth Roy, and this one might be for you, Andrea. He's asking, we've talked a little bit about the habitation modules that are being considered now, and we've already also talked a little bit about robots. He goes, are you planning to send robots to set up the habitat, or will you be using something like inflatable modules? What's the general? Can you give us a sense of the overall thinking involved in the modules and getting us to Mars? What might be, without getting too specific with some of the things that you might be considering now?
Well, for getting to Mars specifically, I think you're going to need a larger module. We're still developing the strategy for an initial cislunar habitation. So it's really going to depend on what path we go down.
I see. And are any looking more attractive than others, or is it just too early to tell right now?
I think it's too early to comment on that right now.
Okay, all right then. So Richard Fisher is asking, we talked, goes to something Alberto brought up and that you also commented on as well, Sam, but he goes, what about artificial gravity? Are there any plans or concepts to address that challenge? Now, we've talked a little bit about the the disorientation one would have from a lot of these rotating structures, but is the plan, do you think, just to deal with not deal with that, at least in the first missions to Mars?
Yeah, I think that the key thing to go to Mars is to shorten the time period. Shorter the time period to get to Mars and get back, the better.
Well, let's talk about that before we leave it then. There's this path, it's called the least effort, is that what it's called? The path to Mars, where you leave Earth in a certain time of the year in its orbit, where it is short. It's got the shortest path to get to Mars.
So Mars and the Earth, it goes episodically. That sometimes it's closer, sometimes it's further on a known cycle. So the nearest cycle is coming up. I know, Harley, in 33. 2030.
Well, there's one in I think there's one in next year or the year after.
Right.
And then you're right. I think it's about, and boy, this is kind of embarrassing. I think it's about every 13 years.
13 years.
Another one in mid-2020s. But yes, then there's a major one in the early to mid-30s.
Yeah. But I think the one in 18 or 19 is the one of SpaceX trying to get to, right?
Right.
The launch.
They're trying to get to that one. But in general, it's anywhere from 6 to 9 months.
Right, and that's the point where the Earth is starting to catch up with Mars, right? As the Earth is traveling faster, spinning or revolving faster.
That part happens every 2 years. So
right, and that's not what we're talking about then. We're talking
about.
Okay, there's another alignment that takes it within 6 to 8, 9 months, and that only happens every would you say 13 years?
Yeah, something like that. 13, 14 years, something like that. And it's and there's an attractive relative orientation between Earth and Mars every 26 months, where you can travel, you can get your payload to Mars with relatively lower energy than you can at other times. So we shoot for those. Our satellites shoot for those. But in addition, on top of that, there are even more attractive relative orientations of the Earth and Mars, where it is even less. It takes even less energy to get between here and there, or you can send a bigger payload for the same energy.
Right.
One is coming up in the next year or two. I forget exactly when. Another one then in early to mid 30s, 2030s.
All right. Well, George Caldwell is asking another really interesting question, and I think a lot of people think about it. And you got to have it when you're talking about Mars. He says, has terraforming in the more distant future been considered for full-time human habitation, or is it too early to consider? And George, let me just comment real quick. I was recently learning something about NASA's MAVEN mission, whose main job is to study the atmosphere of Mars. And the atmosphere of Mars is actually eroding. It's actually being blown away by the solar wind at a rate of, I think it's 100 grams per day or something like that. So any terraforming that one would have to do, remember there's not much of a magnetic field there on Mars either. So there's not a whole lot of protection from things like the solar wind. So if you're going to terraform, you need to really think about a lot more than just adding atmosphere. You're going to have to somehow figure out, I think, how to get a magnetic field there too. So I don't know. Do you guys have any comments? I know it's way, way early. We're just trying to get to Mars. But any comments on terraforming, or is it something we even should do?
Yeah, well, I think just from my perspective, let's figure out how to get there.
Let's just get there, right? I agree. But that's a good question.
Figure out how to get there.
Once we get there, then we can leave a little plant that grows.
Yeah.
Just one. That'll
Potatoes.
Just one.
Potatoes.
George, Patrick Freeman, I hope I said that properly, is asking how large. Maybe this is something for you, Andrea, if you feel like this might be something in your expertise range. It says, how large should the spaceship be, room-wise, to transport the first human mission compared to, say, the ISS? How big are we looking at here?
Well, we have some health requirements related to that. I don't know the specifics offhand. Sam, do you know?
Yes. So the human space needs to be about 100 cubic meters.
That's per person, right?
No, that's for 4 people.
For 4 people?
That's for 4 people. Now, the entire spaceship includes all logistics.
Well, you better really like the people
be
you're
like
with,
each other and be be very friendly. 100 cubic meters.
Now, the spacecraft will have to be larger than that, but that's the habitable part, or if you will, the space that they need to occupy. The spaceship itself, the interior, needs to be about 300 cubic meters for all the supplies. Everything else, your systems and everything else. So it's not spacious. The space station itself is the size of a large 5-bedroom home. So the space station is big.
One thing you may want to do, Alberto, why don't you show back the 4 concepts in the program that Andrea has oversight for, because they were drawn, or they're artist conceptions, of course, but some serious thought have been given to all of those. They are shown in approximate scale with some things you may know, like, for example, Orion there. And for example, the Orion spacecraft, which you see in 3 of the 4. And what is the Andrea or Sam? What's the relative size of Orion? Say the relative diameter of the Orion spacecraft?
Gosh.
About 12 meters.
Yeah, something like that.
I
think that's quite.
want to point out these charts. You know, I'm not exactly sure they're drawn to scale. They're really just concepts, basic concepts.
And they don't all.
I think some of them are just related to initial habitation, not necessarily.
Yeah.
Right.
These are
Right.
True.
Yeah.
Exactly. Well, these at least 2 of them have been presented publicly elsewhere. Once again, in the spirit of a basic starting point concept study. And you're right. I think a couple of them are missing some of the key elements. But it will give your readers, your listeners, the viewers, some sense of scale.
But I'm assuming, actually, I think that's a great point, right? I'm assuming that the calculation of the space then necessary to perform the duties, live comfortably for long periods of time is part of the calculation when you make these modules. I mean, it cannot be a random thing, obviously.
No, it's not a random thing. And, NASA's been studying this, gosh, for, 50 years. So there's all kind of concepts, there's all kinds of layouts and things of that nature that's happened over the years. But now all those things are sort of like coming to a head now, and then it'll be coming to the head in the next few years now. What are we actually going to build? Because now it's going to be, we're building the rocket, we're building the crew capsule, we're doing all the research now. Now soon it'll be time to say, okay, now pencils down, let's build the Mars spacecraft.
Which brings up a question, Sam. Again, I think this is a question once again for Andrea, for either of you, with these phase 1, phase 2 studies that Andrea is overseeing. Is there a date, even approximately, when one of those will be, presumably, one of those will be selected? That's the design that we want to build, and construction will begin for deployment in the mid-20s. But is there a time when NASA intends to start advanced design and construction of one of those?
Well, right now, we're wanting to keep multiple companies involved into the phase 2.
Right.
And the phase 2 will culminate. They're going to be maturing their designs, and then also we've asked for a ground prototype development. And we're also interested in how our investments can stimulate commercial LEO habitations. But all of the next phase planning, all of phase 2 will feed into that, and also our discussions with the international partners and what we decide on interface standards. So it's about all I can say for the follow-on phases right now.
So quite a few years yet ahead. Yes. At least several years.
All right, well, I got a couple of quick comments I want to read out before we run out of time. Neville Madden is commenting it's 2018 that they can do a slingshot journey, so that's what I think Alberto was saying.
Yeah, thank you.
2018. He also has provided a link to the Outer Space Treaty at state.gov, so I'm going to I will put that link in the description box of the Hangout after it posts, after it processes and posts in just a minute. And then finally, Andrew Planet is commenting again on terraforming. Wouldn't it be easier to terraform with greenhouse gases with radiation filters rather than create a planetary atmosphere? Probably. I don't know, but that right now it's like we're talking about here. We just want to get there.
I'm an engineer, man.
Yeah, I mean,
I'm an engineer. Yeah.
Okay, so
well, we should start thinking about how not to destroy the atmosphere on this planet first, before we actually know how to do that, right? On the other planet.
Don't get me started. Okay. All right, folks. Well, we are out of time. Thank you all very much for your great comments and questions on Twitter. I appreciate that, and we are currently working on a technical solution to the live chat situation. Hopefully by next September, it'll be in place. You can follow these discussions by subscribing to youtube.com/deepastronomy, and you'll be able to get notified of these things. So I hope you guys will do it. I want to thank both of our guests, Sam Scimemi, thank you very much, and Andrea Riley for taking time out of your day to talk to us about the ISS and getting to Mars. Next month, Harley, do we have anything, or is it too soon to be asking you for our topic, Mike?
A little bit too soon, but it will be in the. We know that it'll be in the spirit of Footsteps to Mars. Once again,
I hope so, because that's our Hangout name.
In the spirit of what do you need? Oh, go away.
All right. Well, thank you all. Thank you very much. I hope you guys will stay tuned for next. Remember, next Thursday. It'll be the first Thursday of the month, and then there'll be every Thursday after that, starting in September. So thank you all.
Oh, by the way, I remember what it is for our next
There you go.
It's SLS and Orion.
Ah, the Space Launch System and Orion, the things that we just were mentioning earlier today. So, all right, that'll be a good one. So, thank you very much, and hope you guys will tune in next month. We'll see you guys then. I want to thank everybody for watching on behalf of Harley, Thronson, and Alberto Conti. Thank you all very much, and as always, keep looking up.